Okay, this is a little bit of a mathematical video teaching you about equations and how to shift bits to the other side of the equals sign. So if we've got an example, say 2x plus 6 equaling 4, okay, just a very mathematical example. We want to get maybe the x or the 2x bit by itself. In fact, let's just get rid of the 2 and we'll keep it really simple. So we want to keep the x by itself. Now, because this part on the left hand side is equal to 4, equal to the part on the right hand side, we can't just remove the 6. We can't just say x equals 4. So if we went like x equals 4, it wouldn't work. It wouldn't be correct. Having a little bit of trouble with my stylus, excuse me. So that doesn't work. You can't do that. Because as soon as you take 6 off the left hand side, you change the balance of it. So it's like removing, say, that little square from the seesaw. So now this side is going to tip down. Okay, and that's a problem, because now we're no longer equal. So if we take away that from that side, we have to also take away an equivalent kind of shape and size, or just an equivalent amount, when we're talking about the equals sign on this side. So how do we do that? Okay, how do we do that? My way, which I think is really easy, is just to write it exactly as you would like it. So we've got our x plus 6, and we're wanting to minus 6 from that side, because that'll get rid of that 6 that's already there and leave the x by itself. So if we do that to one side, we've got to do the same to the other side. So we can go 4 minus 6 as well. Do you see what we've done there? So I've subtracted 6 from that side, and we've done exactly the same thing to this side. Okay, and now what that's going to allow us to do is to cancel out the 6's, leaving the x by itself. And then on this right hand side, we just have to recalculate it. So I'll just move down a wee bit, and then we'll do the final calculation. So the answer will be, as soon as I get that, there we go, will be x equaling 4 minus 6 is going to be minus 2. Okay, so 4 minus 4 is 0, but 6 has got 2 extra that we have to take away, so that's why we go to the minus 2. In fact, it's worth just doing a little side note on these sorts of subtractions. A really helpful visualization is to say 4 is that you've got, here's some ground, you've got 4 piles of dirt, okay, all the same height, the same amount of dirt, okay, and then you've got, because you're subtracting 6, you've got 6 holes, 3, I'm going to have a little bit more space, but you've got 6 holes in the ground that are equal in size to those 4 bits. So 4 piles of dirt and 6 holes. So when you're subtracting negative 6 from 4, it's kind of like you're filling in 4 of those holes, and you're leaving 2 holes remaining. So if we represent that with green, we'll cross that out and that out. So we've filled one hole in, cross that out, we've filled another, and so on and so on. So we're left with 2 holes. 2 holes equals minus 2. Okay, and that's why we can come up with the minus 2 on there. So let's do one more example, and then I'll leave you to go and practice what you have. I'm going to use it as a physics example, so we're going to step it up just a little bit from there. And the example will be from a kinematic equations. So we have D equals VIT. Okay, I realise this is getting a little bit more complex, but half a t squared. With this, because we have to make it relate into our physics. Okay, with this, sometimes we will have some numbers that we put into there. So we might know what the initial velocity, what the time is, and perhaps even what the acceleration is. No, we'll say we won't know that. Let's say we know the distance is 4, and we know the initial velocity is 6, and we know that the time is 1. Okay, so VIT is 6 times 1. So that means we're left with half A, and the time was 1, times 1 squared. Okay, so I'm just working through getting to the same sort of point that we would have from the above example. And we have, oops, excuse me, oh, never mind, I'm back on. So we've got 4 equals 6 plus, now half A, oh, I've made an error here. I'm going to make our time equal to 2. So this is going to be equal to 12. Okay, this is just going to make it a simpler example. So then we're left with 2 squared, which will give us 4. And 4 times half times A is 2A. Okay, there's a whole lot of other things going on here, and I'll just run through it again once I've got to this stage to make it a little bit more comfortable. So we're left with 4 equals 12 plus 2A. Okay, and if I can just say all of the rest is irrelevant up here, we're only interested in this because now we can work with this to find A in the same method that we used above to find X. Okay, so the main idea was that we were just using a physics example, and this is the sort of example that people tend to muck up. So let's carry on with it. And what we did was we just substituted some values in for d, v, I, t, and then we ended up with this equation. So let's just go from this equation and do our little bit of calculation that we're trying to assess here. So we end up with 4 equals 12 plus 2a. We want to get the 2a by itself because that's just got the a section in it. So we have to subtract 12 from both sides. Okay, I'm doing it kind of quick, but we'll go through again. So we've got 12 plus 2a minus 12. So you can see that we've subtracted 12 from both sides. That's the only difference between this part here and this part here, between those two lines. So that minus 12 we've added on. On the right hand side we can cancel out the 12 and the minus 12, and then we're left with just 2a. But on the left hand side we've got 4 minus 12. So we've got 4 of those piles above and we've got 12 below. Let's just keep going, 7, 8, 9, 10, 11, 12. Okay, and so 4 of those will cancel, 1, 2, 3, 4, and then we're left with 1, 2, 3, 4, 5, 6, 7, 8. But the 8 holds, so it's negative 8. Okay, and then you can do the rest of the calculation yourself because we've successfully moved the number across, and I think you can see that a would equal negative 4. But that's for another video. The main thing is to get to that point there. Okay, I hope that's helpful for you. May help your maths as well. But what I think is just really important, 2 key things to emphasize, is that when you're moving something from one side to the other, you have to do the same on both sides of the equals sign. Okay, the same on both sides of the equal sign. And the other thing is to use those holes to help you visualize adding and subtracting.